I am going to do these problems and show you how they're done. These are very similar to what we've done before. Let's go ahead and solve these. The first equation deals with a y squared and a cosine of y and an x to the fifth and a constant number. So we're going to take the derivative with respect to x of the left-hand side and then take a derivative with respect to x of the right-hand side. I'm going to do this pretty quickly because we've done a lot of these before. So derivative of 3y squared with respect to x is going to be 6y to the first times y prime. The derivative of cosine of y is negative sine of y times y prime. The derivative of 8x to the fifth is 40x to the fourth. And the derivative of 32 is 0. Solving for y prime is our only issue now. So we subtract 40x to the fourth from both sides. That'll give me 6y times y prime minus sine y times y prime equals negative 40x to the fourth. Now we factor out y prime. We end up with 6y minus sine of y on the inside equaling negative 40x to the fourth. And then divide both sides by 6y minus sine y. We end up with negative 40x to the fourth over 6y minus sine y. And that's the y prime. That's the derivative of y with respect to x. Let's take a look at the next function we are asked to do. So let's take this function and take a derivative with respect to x of both sides. The left-hand side is going to require me to do a power rule and a chain rule at the same time. So I look at 10x to the fifth and I view that as my f, and I view my g as y to the seventh. So derivative of f, 50x to the fourth, times normal g, y to the seventh, plus normal f, 10x to the fifth, times derivative of g, that'd be 7y to the sixth, times the derivative of the inside function, which is y prime. Derivative on the right-hand side, it would be 81 times 4, which is 324. That number is going to be multiplied times x to the third. Then we will add 17. I am going to do two steps at once. I'm going to multiply the 10 and this 7. And then I'm also going to subtract the 50x to the fourth times y to the seventh term. So I'm going to do that all at once. Hopefully this doesn't throw you off. So 10 times 7 is 70. On the right-hand side, I'm going to get 324 x to the third plus 17 minus 50 x to the fourth y to the seventh. So I moved that 50, got rid of it on the left-hand side, subtracted it on the right. Doesn't matter what order these three terms are in. I guess if we wanted to do in descending order, I'd put the minus 50 x to the fourth y to the seventh up front, if I wanted it to be in descending order. Now it's a matter of dividing, and negative 50x to the fourth y to the seventh plus 324x to the third plus 17 divided by 70x to the fifth y to the sixth. Now that's a fairly long process, but again, it's a much shorter process than the alternative, dealing with seventh roots of y's, things like that. So it's not impossible to solve this one for y. This one is a function if you solve it for y, but it's much, much easier doing implicit differentiation in this case.